In this video, I want to talk about how to solve a systems of equations by using graphing. So this is typically the first lesson of systems of equations that students in algebra or maybe even pre-algebra are exposed to. And the idea of systems of equations is that we are given two variables that we can't solve for in an equation. Typically, in an equation, we need one variable only, and in which case we can use our algebra rules to solve. So if I have an equation such as x plus 2y is equal to 5, and when we graph it, this is what the graph will look like. So I'm using the graphing software in Desmos to do this for me here. And I'm not going to get into how to graph the line in this lesson, but this would be the graph of that particular line. Notice that we have two variables here, x and y. So we can't get a solution from that because, again, we have two variables. What we need in order to get a solution is we need a second equation with the same variables. Okay, so what ends up happening then is a solution to a system of equations is where the intersection occurs. Right, so if I come up with another equation, okay, 3x minus y equaling to 8, we find that when we graph the second one, they intersect at the point 3, 1. So 3, 1 would be the solution to this system of equations. Again, why is it the solution? Because it's where it intersects at. Okay. Now, with that said, there is a possibility that we could have no solutions for a system of equations. So, for example, okay, if you look here, I have another equation listed. So 3x plus 6y equaling to 15. And what you're going to notice is, my formatting is all over the place. Okay, and what you notice when I go up and back, there's only one equation. I'm scrolling through the screen, I can't find it. So in this case, we just talked about having possible 0 solutions, but in this case, what we're going to find out is that there's infinitely many solutions. Okay, so what occurred is from the first equation, if I multiplied the bottom one, if I multiplied the original by 3, then I would get 3x plus 6y equaling 15. So I'm searching for that other equation and I can't find it. And so what happens is that these two are the same identical equation. And you notice when I clicked off, the red line now appears. So if the two equations are identical, that's called infinitely many solutions because a solution is where the lines intersect. And in that case, if they're the same line, then they have a solution at every single point of the line. Okay, so now what happens then if we want to do something else? So let's look at a different type of equation. Y equals 3x minus 5. Okay, and we see we have our equation here. Now let's do another equation. Y equals, and we're going to use the same slope this time. Okay, y equals 3x minus 1. What just occurred then? Well, when we look at the equations, we notice that they are actually parallel lines. And we know from prior lessons that parallel lines do not intersect, and they also have the same slopes. Algebraically, they have the same slopes. Geometrically, they never touch. So if they never touch, we can't have a possible solution for this. So if we have two equations that end up having the same slope, or they happen to be parallel, based on what the problem gives you, then we know there is no solutions for that system of equations.